Hello, welcome to another video on how to solve ODEs in Python. So this is a simple problem. So where you have one differential equation and then you have some parameters and you want to solve it in Python. So if you've not watched my previous video on how to implement a model on Python, I'll recommend you watch that video before you watch this video. So in this video, we have this problem. A mass balance for a chemical in a completely mixed reactor can be written as V dc dt equals F minus QC minus KVC squared. And you have the parameters here. So the initial condition is C at time t equals 0 equals 0. And you want to solve the ODEs. First, some time. So how do we do this in Python? Okay, so here you need to import the packages that you need. Here we need we need NumPy. So we import NumPy as NP. So this is like an alias for NumPy. And then from SciPy, we dot integrate. So we import solve underscore IBP. So that is the solver we want to use. And then we import matplotlib.pyplot as PLT. This is for plotting the result. So first we define the parameters. So these are the parameters that we have, V, F, Q, and K. And then you define a function. As you know, in Python, you have to define a function for the ODE, and then you pass that function as an argument to the solver. So define the differential. So dc dt equals uh, this. So we have to write the derivative as equal to everything else. So you have to, if there's any variable on that is multiplying or dividing the derivative, you have to rearrange it such that you have only the derivative on the left-hand side. So that is what we have for that problem. So, and then you return the right-hand side. Then you specify, the t underscore span is how long you want to run it. You want to run it from 0 to 30 in this case. And then the t eval, as you know, what are the specific time points that you want to solve the problem. So here you need 200 points between 0 and 30. Then your solution, when you solve it, you store your result in SOL and you called solve underscore IBP. Remember, IBP means initial value problem. And then you pass the function, which is previously defined. You pass the time span. Then you specify the initial condition, always as a vector. So you must always specify it as a vector. So if you have just one initial condition, if you want differential equation, you just put only the initial condition for that. And then you specify t eval. So you want to evaluate it at this specific time point. And then you plot the function. So what you're doing here, you're saying that you grab t from sol. So sol.t, and then you grab y from t, but now you're grabbing the first column of y of that matrix. So and then you plot this 0 means the first column. And then you plot, this is the the x label is time, y label concentration, and this is the title. You include the grid if you want, and then you show uh, the results. So if I run this, then I should have the results. Yeah, so this is the result. So you have the concentration as a function of time in minutes. Okay, so that's it for this video, and I will see you in another video. Take care. Bye bye.